Tesla Cult here, and I'm working on a circuit here for my rotary coil, an electronic circuit here, so I can get some frequency control on the rotational speed of the field. And I wanted to give a little discussion on phase shifting, and maybe show some people exactly what I'm doing here. So anyway, this is my circuit. I'm using the onboard signal generator on my prototyping board here, but I got a two-stage amplifier, and let's turn it on and have a look here. Okay, now currently the frequency is at around 34 hertz. And you can see that the two signals are pretty well in phase with each other. And as I turn this up, we're going to watch what happens to the phasing on the signals. Now, what I'm going to bring up here is that I'm using this capacitor here to phase shift one of the legs on the rotary coil. And the issue with this is that it has a specific frequency at which the correct phase shifting occurs, and we're going to take a look at that right now. And here's my screen, and as I gradually increase frequency, we're going to watch what happens here. And it's starting to change now, and we're up to 53 hertz, 56 hertz. I'd say right about there. Yeah, right there, right at 60 hertz is our ideal phase shift. Now, this was the capacitor that I used when I was demonstrating with the AC, just the 60 hertz AC as the driver, and as you can see, I get just the right phase shift at 60 hertz. With this configuration. Now, if I continue to raise the frequency, as you can see that the phasing gets off, and eventually the field no longer rotates. So anyway, let me you can hear the magnet. The magnet vibrates now. This is with the correct phase shift, and as it goes out of phase, it stops vibrating. Back into phase. I'll take it out of phase the other direction. Well, that's the low frequency. And bring it back into phase. But anyway, so let me give another demonstration here. And what I'm going to do is I'm going to swap capacitors out. This is another capacitor here. And I'm going to replace the current capacitor with this other one. And watch what happens to the frequency. So let's turn it back on. And as you can see here at 60 hertz, the two signals are pretty much in phase, so I'm going to start raising the frequency. And right about there is our correct phasing, and now we're hitting the correct phase shift right around 100 hertz, and with the slightly smaller capacitor. So, and let me take it up past that again. We'll keep increasing frequency, and that's the end of this one. I'd have to, as you can see, as I raise it, it goes out of phase. So let's try this one more time, and we'll hook up an even smaller capacitor. I should turn it off. And Let's watch what happens. Okay. And 100 hertz, again the signals are back in phase. And I'm going to raise the signal. You can see some distortion here. But right up, here we go. So right about there is our ideal phase shift. So with the third capacitor, the resonant frequency, or the ideal frequency, is 285 hertz. So anyway, this is obviously this limits frequency control to an extent, because frequency has to be correct for the layout of the coil, and I'm going to correct that by altering this circuit. I'm going to build some phase shifters into the circuit so I can actually adjust the phase shift on the fly, so to speak, you know, independent of the frequency. But that's going to take some more work, and obviously this circuit's not really powerful enough as it is. It's the field's nothing compared to what it was connected to the 60 hertz mains, and it's just going to take some more work. I need a bigger power supply because this one's 12 volts, about 1 amp max, and that's just not going to cut it for pushing this this transformer. So anyway, that's it. Tesla Cult signing out.